Let's take a look at the air interface technologies and how these technologies are quite different depending if you come from an open network or a closed network philosophy. There are also different evolution paths towards fourth generation networks because both the telecommunication companies as well as the netheads and the wireless internet environment that they are proposing, all of them have got a unique point in the future that they call fourth generation networks. But both of these different camps believe that the future can be reached by two totally different paths. Let's quickly take a look at the difference in these two philosophies. The evolution path of fixed and mobile networks can really be defined from both the mobile cellular provider side and then the internet community environment. If we take a look at the mobile side, in the past we had mobile wireless networks, and the upgrade on top of the wireless mobile network was to provide wireless internet access. That was the next major step. So from technologies like GSM, companies started implementing technologies like GPRS or General Packet Radio Service, which allows mobile data access via the cellular infrastructure. We are seeing of late is that mobile wireless IP multimedia functionalities are coming to the fore, especially with third generation services where you can make video calls or you can utilize the mobile environment to look at video clips or to send pictures. And all of this allows multimedia functionality via the cellular environment. What we are therefore seeing is that cellular is moving from the voice environment to a broadband and packet switched environment. And the traditional business model behind this is to allow the cellular companies to make more money per user, or ARPU, as people call the average revenue per user. That was the key focus of allowing these data services to allow their users to have far more functionality than just a normal voice communication between individuals. A totally different approach towards fourth generation networks exists in the internet space. In the environment of the internet, we see that IP data services were available over fixed networks, and this has been the case for a number of years. We saw next revelation that IP services became available over nomadic mobility infrastructures. That meant that Wi-Fi hotspots became available in a number of places, and that nomadic or wireless access became a reality in order to access the internet from any position within reach of a Wi-Fi hotspot. We're also seeing enhanced IP services that can now provide voice services and video services. And this is mainly a function of the increase in bandwidth, where you can provide a certain level of quality simply because the bandwidth has increased dramatically over the last few years. And this is the position of the internet community that really goes mobile. So we have two different groupings: the cellular networks that move towards the ubiquitous internet from a voice business model standpoint, and the internet community that is moving towards the ubiquitous internet from a fixed internet access point of view. And both have different business models that they base their businesses upon. If we take a look at fourth generation networks, this is where it's all going to end in 4G space, namely broadband mobile multimedia services via packet-based networks. And the two totally different approaches to get to that specific environment. Fourth generation technologies can also be defined from the different departure points from where they come from. So let's quickly take a look at different technologies and why they will reach the same type of service delivery environment via different routes. In front of you, you'll see the evolution of cellular technology. We'll move from second generation to 2.5G, this is technology like GPRS that we're quite used to by now, to technologies that is called 3G, technologies like WCDMA. In America they're called CDMA 2000 or EVDO. And then we see an upgrade of these technologies to make them quicker and faster. In most places, in Western Europe and other parts of the world, 3.5G will also be called HSDPA, or high-speed downlink packet access. And this will allow the traditional 3G systems to allow far faster data communication speeds. All of these technologies are based on standardized, closed architectures that is made available via the mobile cellular operator space. By taking a look at what's happening in other environments, we're also seeing the wireless LAN or metro nets becoming of age. We're seeing that Wi-Fi or wireless LAN technology that allowed short distance communication, and how all of that is changing with the advent of new technologies like WiMAX. What is interesting to note is that the technologies on the right-hand side of the screen at the bottom are technologies standardized by the IEEE, or the Institute for Electronic and Electrical Engineers. The technologies you see at the top left-hand side of the screen are the technologies standardized by the ITU and organizations like the 3GPP, the 3G Partnership Project. All of these technologies, however, have got one wish in common, and that is to dominate the fourth generation ubiquitous internet space. But a number of other technologies are also available, non-standard technologies. These are technologies like Flash OFDM, technologies from IP wireless or Arraycom that are really proprietary by nature and that hasn't really been standardized. These technologies are owned by specific companies, and they also enable the users to have access to the internet. So you have three groupings: the mobile environment, we have the IEEE that are standardized and open technologies. Anyone can really manufacture them. There's no royalties to be paid on any of these technologies. And then we have the proprietary technologies that are really owned and controlled by a number of key organizations in the world. So three different approaches that is going towards the final goal of mobile broadband access. And these are some of the key elements that we can focus on in the fourth generation or evolved third generation space. There's another technology we'll need to focus on, and we'll talk about that a bit later, and this technology is called mesh network or ad hoc networks. And these are small little piconets that does wonderful things. Mesh networks can be described as one base station becoming a relay station for all the other stations around it. So where all the other technologies we looked at, they can be defined as a technology with a base station and then subscribers around it connecting directly to the base station. Mesh networks work slightly differently. What we see here is that one mesh network, a minor or small base station, will connect to any other base station, and if you want to connect to the internet, there's a hop over effect of your package going through all of these different base stations until it reaches the point where it connects to the internet. And this mesh network environment means that there can be literally millions of small little hotspots, and you can then hop over these hotspots until you reach the point where you can log out onto the internet. But let's take a look at some other technologies and how they will have an impact on the world around us. If we take a look at the technologies, we can classify the controlled network philosophy and open network philosophy technologies as follows. On the one end, we see standardized technologies becoming quite important. And we looked at the two standardized technologies, the one from the cellular environment and the other one from the IEEE or internet environment, the NetEd technologies. The standardized technologies currently can be defined as a guerrilla game. What do we mean with the word guerrilla game? One of the key companies that facilitate both WCDMA and CDMA 2000 technologies is a company called Qualcomm. And every single time that a network operator or vendor installs third generation technology, then Qualcomm will get some money from it because they hold the key patent rights to the CDMA technology worldwide. And therefore, although the technology has been standardized in the cellular environment, one company holds all of the patents. And that's why it's so interesting to see how a small company like Qualcomm have got a massive price-earning ratio on the stock exchange.